Hello, everybody, and welcome back, sports fans, RVers, and followers the world over. I'm Joe Symmes with Fixin RV, joined by my good buddy and co-host, John Vanek, Ridgeback RV Services. John, how are you today?
We're doing well in beautiful northern Nevada, Joe. And we always talk about the weather a little bit. It's kind of the same thing as last week. It's cooling down. And we're going to talk a little bit about furnaces today because there's a lot of things about furnaces that I think most RVers don't understand. And actually, even some RV techs don't always pay attention to. So we have some tips later on today that are going to be valuable for RV techs, but certainly for RV owners and having a better understanding of how your furnace works and what some of the potential issues might be, some of which you've probably never even heard of. But before we go there, we open up with our Beside the Pedestal segment. But the last couple of episodes, we haven't done that. We've had other things to focus on. And so our Beside the Pedestal segment really tries to focus on tips and tricks. Many of you experienced RVers might be familiar with most of them, or maybe even all of them, but they're good to revisit on occasion. And they're also valuable tips for newer RVers and also, again, for RV technicians. So, Joe, tell us about the Symmes Wiggle Test.
So as our longtime fans know, we have military and law enforcement background here on the show. And so, of course, that means we like our TLAs. For those in the know, those are 3-letter acronyms. So, yes, John dared me before the show started to call it the SWT. So,
there we
sure
go.
enough,
SWT.
we're going to have our fans will forevermore say, "Hey, I opened up my battery compartment and I did the SWT, and sure enough, you were exactly right." So, what is
so your SWT should be part of your SOP.
Exactly. I love it. And this is, of course, our fans learn this in the BTP segment of the podcast.
Beside the pedestal, for those of you that are not keeping up.
I tell you what, our fans, John, are the smartest and best around because they have to be to keep up with this humor. That's for sure.
Well, I think it's part of what happens when you subscribe to the Smart RV podcast is you become very smart.
You're instantly smarter. And we can prove that because when you sit around the campfire and our fans will say, "Yeah, I was watching Smart RV last week, weren't you?" And instantly you've got street cred right there.
There you go. There you go. So tell us, what is the Symmes Wiggle Test?
So boy, after that, prelude and lead in, this better be something great, right? Yeah, sure, it is.
It is good. So that's why we're sharing it.
What the Symmes Wiggle Test. Anytime, I'm sure somebody else invented this. It probably goes back to the Egyptians at the pyramids. I'm not sure. But when I am encountering a battery in the wild and looking at someone's RV and in the battery bay, in the battery compartment, if you've got a motorhome and I've got the battery rack tray slid out.
You might have 10 batteries in that tray.
Yeah.
That's a lot of batteries.
SWT works on one or more batteries.
Okay.
So the only tools you need are digits. And so you carefully reach and grab the insulated part of your battery cable. Nothing else, not any of the connections, just the insulated part. And you go like this.
You wiggle it.
And
for those of you that aren't watching on YouTube and are just watching this one, Joe is miming wiggling
the cable. Yeah.
Wiggle the cable.
You can imagine someone wiggling the battery cable and then be that person. So what you're doing, free, easy, fast, light, you always have your hands with you, so you never leave home without them. Great to do, because what that's going to tell you is how firm your connection is, how tight that lug is, and you can put a wrench on it, you can make sure it's snug, and that's good, and you should probably do that before the end of the day. But if nothing else, next time you walk by your battery, just give it a quick wiggle, because you'd be surprised how often the cable moves any. And in this test, the metric is 0. Do you want a quarter inch play? No. Do you want an eighth of an inch play? No. Do you want 30 thousandths of an inch play? No. When
Because
you,
what's the downside if there is play, or I should say more correctly, the potential
mm,
downside if you have play in your battery cables
yeah,
on the coast?
loose battery cable, loose connection, loose post, loose screw can lead to a poor conductivity connection. In other words, a high resistance connection. And so that's going to limit voltage flow. It's going to increase current requirement to make the wattage needed for motors on the other end. It's going to create heat, could potentially make arcing, which could eat away at some of the coating on the metal on the cables, which could eventually lead to deterioration of the metal surface, um, more and more corrosion buildup, things like that. So, bunch of reasons why batteries should be firm, snug, tight, no play, no wiggle, no give. They don't strip them out, but other than that, tighten them down good and firm.
So I'm going to throw out here something, and I'm going to throw up some photographs here in a second. But when you're wiggling those cables, it might not just be the end that's on the battery. And I want to show. I'm going to put up. I was checking some battery cables recently, and the photographs that I'm putting up on the screen right now, they're showing the positive cable coming off the battery, and where that battery goes into a power distribution block on the frame, the cable came out of its lug.
Oh, that's bad.
Yeah. Yes. So in this case, if that had happened on the road for the client, it'd be a total failure. They'd be like, I don't have any power.
Right.
And if we look closely at these photographs, the first one I have here is the as it came off, you can see lots of electrical tape around the end of the cable, and you can see the lug sitting there. It's a very poor crimp on that lug, and there's actually a lot of corrosion, which is probably partly due to this poor electrical connection. But then the second photo, I've taken the tape off, and you see how little amount of wire is actually coming out from the insulated portion of the cable.
Wow.
And you can see that the shrink wrap, the red part there, the red plastic, that should have been also going around the lug itself, around the crimp. So
Yeah.
I suspect that the manufacturer, the assembler here, realized that they had a shoddy connection. And rather than redoing the cable properly, they just threw on some electrical tape.
Yeah.
So
Covered it
here's
up.
an example. Covered it up. That's right. And not good. So there's my example. But the wiggle test, the SWT, the Symmes Wiggle Test, is not only applicable to batteries, but also to other areas of wiring in the rig. And don't you have an example you want to share with us?
Yeah, so thank you. We're going to now gently transition to a little more deeper topic than a beside the pedestal necessarily. But yeah, I wanted to mention in my call of the week, John, that I had a call recently and customer had kind of some weird electrical things going on. And one of the devices that wasn't operating properly was their inverter charger. And this is a motorhome with an inverter charger.
Hmm.
And so I followed the trail of power, in this case, 120 volts AC. First thing I did, they were plugged in at their house and had good connection, good shore power. In other words, no problem there.
Okay.
Went into the transfer switch, came out of the transfer switch, everything looking good. I went to the power distribution panel next and checked the two hot, it was a 50 amp rig. So the line one and line two, the two hot legs.
Okay, before we move on, just for some of our newer RV owners that might be listening, can you tell us what the power distribution panel typically looks like, so
It,
people know what we're talking about here? This is
yeah,
not
thank you.
buried. This is should be visible. It looks like.
Yeah. Yes. Looks like the breaker panel at your house. The reason in the RV industry they call it that is because there's almost always, 95% of the time, there's two halves to it, an AC side with breakers like you're used to in your house, and a DC
Hmm.
side with different types of fuses, blade fuses, push button reset fuses, but DC lower voltage, 12-volt fuses, as opposed to the AC 120-volt breaker side.
And it's more often than not, it's kind of a plastic panel that's maybe
Right.
16 inches by 16 inches, let's
Yeah.
say,
Yeah.
and you pop it open and you're kind of looking at everything, right?
Yeah, and most RVs, if you don't know where it is, look around. You will find it probably on the floor, lower area. It'll have a little push to release door a lot of times. Some newer rigs, they put them in cabinets. I've seen them in a lot of fifth wheels, maybe as soon as you come in the door, central cabinet. Some motorhomes, it'll be in the bedroom, sometimes in an upper cabinet. So it's not always on the floor, but it is generally, not always, but a general rule of thumb is it's relatively central so that wire circuits, the wire runs, can go both fore and aft and meet up at this central point. And that's why the proper industry term is a power distribution center.
Okay, thanks. So you had good power. You know your power was good coming into the power distribution center. You opened that up,
Yes.
and what happened then?
Yeah, so following the trail of 120 volts, had good power coming in on normally they're black and red on the two incoming, the mains, to put it in home terms, into the bridged 50 amp circuit breaker. So great, 118 on one leg, 121 or whatever volts on the other leg. That's all within acceptable range. That looked great. And so what I probably coulda, shoulda, in hindsight, done is then go down and test breaker by breaker all the way down. But what I did next was went to the device itself, to the inverter charger,
Uh-huh.
and checked the power there because I knew I'd be able to tap in with my multimeter, tap into the lines there. They wouldn't be insulated. There'd be a connection that I could put probes on. And sure enough, I was getting on the DC side, we'll call it 11.3 volts or so. So, that's kind of unusual. Check the batteries themselves, and sure enough, 12.8 or something like that. So plenty of voltage there.
So if you've got
Now,
12, if you've got a good 12 volts on the batteries, you should have had a good 12 volts going into
right,
the inverter on the DC
right.
side. Okay, great.
Exactly. And so I began to wonder, why obviously I don't have a short, but I'm losing voltage someplace, a high resistance connection. That usually points to either a bad connection or bad ground. So then I went back to the power distribution panel, and we'll probably go in more in depth in this in a future episode, but there's sort of a pattern once you really get into RV electricity, you can start to see it after a while of how power flows through them. And before we get into that deep, though, easy way to say is just start marching down the line, checking voltage on each breaker. And again, you're going to want to, it's probably a little higher level stuff, maybe for a technician or the really skilled DIY folks, but you want to find a good ground inside the power distribution panel to put the black probe on. And then with your red or hot lead, touch the output of each breaker. And sure enough, I go down the line and I'm seeing 120 volts, 120 volts, 120 volts, and I get to one that is, say, 109 volts. So,
Ah,
that's unusual.
because they should all be the same.
Exactly. Yep, it
Yes, they
should
should
all
all be the
be.
same.
Yeah, at that point, you shouldn't have any loss when power comes in on one side of the panel. By the time it gets to the other, that's not a long enough run. There's not enough connections. There's not enough anything that you should expect any loss. It should be the same 119, 121, whatever you start with. So as I began to investigate further, I realized, oh, I think this breaker might be warm. And so we'll put up the picture here and show you can either just kind of observe that with your senses. This breaker's a little bit warmer, or if you've got access to some higher tech equipment, I took a picture with my thermal imaging camera, and
Ah, look at this.
I'm showing that to the customer here. This is well, we'll also put a picture of the panel without the thermal image in it, and then one with, and
Okay.
you can see um, like those fans of Sesame Street and watched since they were a kid. The one of these kids is not like the other. Remember that segment?
One of these is hot.
Yes, yes. One of these breakers is not like the others. Most of the breakers were a consistent temperature, and the thermal image shows one of them is relatively warmer than the rest. Now, was it atrocious? No, it was only a few degrees warmer. But when you have a row of 5 or 6 breakers and only one is 4 degrees warmer than all the rest around, it makes you say, one of these breakers is not like the others.
Yeah.
So secured power, turned everything off, made it safe, and removed that breaker. And sure enough, had a poor connection in the backside of the breaker itself.
So the wiggle test well, you're kind of doing the wiggle test at that point. You pull it
Yeah,
out,
exactly.
you're
It
wiggling, and
didn't.
you're like, oh,
It wasn't. It looked fine at first, but as you kind of started to push on them, those of you that know how breakers snap into place in their positions on the bus bar, it was easy to pull out and therefore not a good connection. And sure enough, when I turned the brake around the backside, you could see some heat residue, some burnt marks. I don't think it had caught on fire or anything like that, but you can tell it had been warmer than the others for a long period of time.
and you mentioned a real hazard in the power distribution panel or power distribution center is that poorly torqued connections can potentially lead to a fire. And in fact, they do. Correct?
Yes, and thank you for pointing that out. What John and I learned in our professional RV education training experience is that there's actual torque value in the lugs. So for the neutral and the ground bus bars, m- most panels will have the panel themselves will have a sticker someplace inside that describes what that panel is designed to be torqued to. But there is a torque value, ladies and gentlemen. And the reason for that is because you don't want to under tighten and have the connections come loose, and you don't want to over tighten, which would either strip them out or smash the wires and cause other problems. So there's a proper range. Well, to your point, John, as I just happened to catch out of the corner of my eye, since I had the thermal camera out anyway, one of the neutral wires was significantly warmer than the others.
Mm,
And when I put the screwdriver on the end of that lug, it was barely finger tight. We'll say
wow.
2 foot-pounds, or I'm sorry, inch pounds. It was almost not even on there.
Wow.
And the customer at this point was kind of over my shoulder and was watching and was with this. And we swear we could hear a little bit of crackle, pop, almost an arcing sound, but very faint in the background. And
Wow.
that's what it was. It was actually a high resistance, bad joint then at that point. So obviously went through and torqued that one down and retorqued all the connections, and most were good. It was just this one that was a little off.
Well, and so going back to the torque values, what's important then is you have to have, Joe and I both carry torque screwdrivers that are measured in inch pounds, and you're going to get different torque values for different bus bars and connections,
Mhm.
and those again, those should all be inside the panel. But this is not like our hands are torqued or our wrists are torque value. We're using actual, obviously professional grade torque screwdrivers, so we can hit those torque values exactly the
Yeah,
way they
yeah.
need to be. So, did you end up then? I'm guessing you swapped out that breaker.
Yes, good point. We were able to find another breaker, and fun fact here, often that doesn't need to be an RV specialty item. As a matter of fact, I kept working on some steps, and we'll have an issue episode later on when we talk about steps. So customer wanted me to continue working on some other issues. He ran to a local home repair store and was able to find the right size breaker. A nice 20 amp breaker, wasn't that unusual, of the same brand and likeness, and brought it back, and I installed the new breaker for him. So we were able to knock that little project out.
Excellent. And while we're at it, when you're in looking at your power distribution panel, and you're, particularly if you're looking and checking these torque values, you've got your hot, you've got your neutral, and you have some grounds, right?
Yes.
And then you have the bus bars, which are the metal bars with holes in it and screws, and that's where the wires fit into, right?
Right. Right. Yep.
Okay. For I'm just helping out some of our listeners that, this might be new for them.
Yeah, and
Some
one other quick tip on those, while there is not necessarily a regulation in the RV industry, there is in home electrical codes, and that is what RV techs call a double tap. So you're not
that's where I was
allowed,
going. That's where I was
yeah,
going.
you're not allowed two wires under one lug in a home wiring system. That would fail code. But since there isn't code in RVs, some manufacturers sometimes on some models occasionally will put two wires under one lug.
And so if I'm looking at a bus bar and I have vacant lugs, meaning no wires are going into those lugs, and then I have a double tap or two or maybe even three that are double tap,
Mhm.
is there any reason I can't loosen those, take one of those and move it over to its own lug?
No, as a matter of fact, that's what I did in this situation also. Had a couple double taps, and the lug we were describing earlier, the loose one, it was one of those. So another reason you don't want to double tap is the physics behind it. You've got a round lug and a round solid core wire. The two can go together and screw down tight and mesh up and hold great. When you put two round wires in one big round lug, sometimes they don't squeeze down flat, straight, square, and can wiggle against each other and cause the set screw to become loose. And I believe that's what happened in this situation.
Got it. Got it. And, for our listeners, if you have a mobile tech come out or you're taking your RV into a shop to be worked on, if you're not comfortable checking these things yourself, ask your tech, hey, while you're here, whatever else you're working on, hey, do you mind checking my torque values in my power distribution panel? Because that is, it's a simple job as long as you have the right tool. It takes maybe 5 minutes at the most.
Yeah.
And it's certainly, it's something that Joe and I both will often use as sort of an add-on, or if we have some extra time, because maybe something else is going on. A couple of weeks or a couple of episodes ago, we talked about servicing tankless water heaters. And those jobs, when you start doing the flush, you got to let it flush for an hour. So there's other things that I could do while the
Yeah.
tank, I mean, I can do nothing. I don't have to do anything once I get it up and flushing. We need an hour, but that gave me time. I do a roof inspection. I go in, I checked all the torque values exactly like this. So
Yeah.
for our listeners, if, this is something very valuable to have examined because there's some real downsides potentially to loose or even over tighten nuts, lug nuts,
Yeah,
screws.
I am also a certified inspector, and the National RV Inspector
That's
Association
right.
NRVIA instruction says that if we find a double tap, it should not only be noted in a formal premier inspection, but we are to mark it as in the life safety category because it
Ah,
is an electrical issue that could potentially cause hazard to life and limb. So it is considered a NRVIA life safety hit if there's a double taps.
wow. Okay. That's good to know. I didn't know that. Okay.
Yeah.
Because Joe's an inspector. I'm not. But that kind of highlights the importance here. Well, thank you for sharing that. And thank you for sharing the photos. And again, kind of going back to our Symmes Wiggle test, understanding how important it is for all of our electrical connections to be proper electrical connections, because they can cause all sorts of problems, including just not having any power at all, but even worse, potentially starting a fire. So, things like this are pretty important.
Yes, and so one last segment closing caution. The patented Symmes Wiggle Test is great for DC, for 12 volts, for batteries outside. Don't please, listeners, please fans, we don't want you to get hurt. Not necessarily a great idea to go reaching around and wiggling and potentially having your fingers slip off of things inside of a 120 volt AC side of the rig.
You might know it.
Yeah, you'll know
If
it.
you do that, you might know it. That's right. Good. Yes. Good point. Ah, so Joe, go ahead.
Yeah, John, no, I wanted to segue to you explaining to us, those of us who understand what furnaces are. They're funny little boxes that make heat, and occasionally I get to clean one out. But you, sir, are the furnace doctor, I believe. I come to you for all my furnace questions.
Oh, well, actually, I guess when I kind of look at all of the different jobs I've had since being in business and I look at the different appliances that I've worked on. I've worked on more furnaces than anything else. And so I'm a friend of the furnace because I like being warm when it's cold, right? Unless I'm out running around in the mountains in the snow and ice. Otherwise, I like to be warm. And 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 there's a lot of great videos out there that go into in depth on YouTube in how to make the fixes of furnaces. So we're not going to have a blow by blow about that. But there's three key points that I would like our listeners to understand. And the first kind of stems from people will have issues with their furnace. Let's not even get into the symptoms, but they'll go on to Facebook is a great place, into an RV forum and say, "Hey, my furnace isn't working. Maybe it's the motor's coming on, maybe it's not. But what do I do?" And about 90% of the answers will be, "Hey, it's your sail switch."
The sail switch.
The sail switch. And the lowly sail switch just gets beaten up. And I am here to tell you, it is not always a sail switch. And in fact, the sail switch might account for a minority of the issues with a furnace. So, I
Maybe that can
promise
be your acronym, John. It's not always the sail switch.
it's not always the sail switch. That'd be a good like license plate frame. It's not the sail switch
Only
on an
only
RV
techs will
tech vehicle.
understand.
Yeah, yeah. It's not the sail switch. I'm gonna be very brief, and then
So,
Joe,
well,
I think you
explain
have
to
a
me,
question.
what is the sail switch?
Well, the sail switch, I think, is actually better described as a prover.
Mm.
Airflow prover, as in it is proving that there is sufficient airflow for the furnace to ignite.
Ah,
So,
okay. So
so
it's
let's
really
look at the
measuring
sequence of operation.
airflow.
It is. It is responding to adequate airflow,
Okay.
if you will.
And
Okay.
before you go further, just to clear up one thing, there is such a thing as a salesman switch on your RV. I just learned this last week. We refer to it, the technicians normally, as a battery disconnect, but in some forums and some places they call it the salesman switch because the salesman hits that when the rig is on the lot, so the batteries don't drain down. So
Ah,
the salesman switch and the sales switch are different things.
two different things. Okay, we're talking about furnaces. So very briefly, when you go to your thermostat and, inside of your rig, it's 65 degrees and you want it to be 72 degrees and you set your thermostat for 72, here's what happens. The thermostat, assuming that it's working correctly, and more often than not, it is, sends a signal to the control board in your furnace saying, "Hey, turn on, get us up to 72 degrees on the inside." The control board sends a signal to the motor. The motor starts running. You hear that right away. And the motor is then going to start moving air around. And at the same time, the control board is also, it needs to have the circuit. And that circuit at this point goes through what's called the high temperature limit switch. And this switch is to make sure that the burn chamber never exceeds the proper
Mhm.
high temperature so we
Okay.
don't end up with a fire. The electrical circuit runs through the high temperature limit switch, and then it comes to the sail switch, which is a micro switch with a thin metal blade. We'll put up some photographs here. And as that motor is spinning up, it pushes the air over that switch and it closes the switch. That tells the board, "Hey, we have sufficient airflow and the burn chamber is not excessively hot, so we can have the rest of the ignition sequence occur."
And so let me pause you right there. This is
Mhm.
why, dear fans, you turn on that furnace and say, why does this blessed thing blow cold air before I'm already cold and now it's blowing cold air on me? Is it even working?
Well, and actually that is proper operation because the way the heat is actually created is eventually we're going to ignite some LP and there is a sort of a circuitous burn chamber
Hmm.
and it just gets hot in there. And we don't want any excess LP gas floating around in there or any other chemicals or anything. So part of this, say 30 seconds, when your motor is turning, but it's not ignited, it's also blowing all of these things out of the RV. So it's another
Okay.
safety feature.
So a
Okay.
gas purge.
It's a gas purge. There's the purge phase. So after the purge phase, then the board now sends a signal to our electrode, comes out of a tower, which is a piece of the board, and it sends it to a wire to the electrode, and it says, oh, before I get there,
Yeah.
kind of about the same time, it is sending a signal to the gas regulator, the gas valve, saying, open up,
And that's a
and
little
so we can
solenoid,
ignite.
right?
Well, and so you have the valve and you have two solenoids typically, which are electric
Okay.
switches to open the valve.
Okay. Got it.
So when we come back here and we look at all of the potential points of failure, solenoids is one, but the valve itself could be bad too, because there's an orifice that
Oh.
could be blocked and other things. So coming back to the sequence, the board tells the valve and the solenoids, hey, open up, let gas through. The igniter then begins to spark to ignite the gas. And when it's operating properly, as soon as it ignites, that same electrode, there's a second piece to it, it's measuring milliamps of connectivity through the flame itself. And it is proving that there is a flame going. And we call that a flame sense because it's sensing the flame.
So what you just said, sharp listeners probably got, and this is a good, literally around the campfire trivia. Fire is a conductor. You can pass voltage through a flame.
Because you have carbon in the
Carbon.
yeah. Yes, 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 yes. So at this point, if the flame sense says, "Yep, I've got a flame, everything's good," now your furnace is going to run and and pro- it's producing hot air now. It's pushing that hot air, warm air into your RV. Things are warming up, and then eventually your thermostat is going to hit 72, and the thermostat's going to say, "Hey, it's warm enough." It's going to tell the board, "Hey, we're
Mm.
warm inside. Go ahead and shut everything down." So what happens first is the gas valve closes, the flame shuts off, and then you have that purge cycle again. The motor's
Uh,
going to continue to run. So it's blowing out any excess LP gas, anything else, exhaust, that blowing it out of the system. And also important that some people don't recognize is that blowing action for another 60 to 90 seconds, that's also cooling down the components
uh,
inside the furnace. So for our techs that are listening, this is when you're bench testing furnaces. It's a good idea to, if you've been running the furnace for any length of time on a bench test, don't just purely cut the power to the furnace, because if you cut the power, then it's going to shut down right away. And you can end up with issues because you haven't allowed the components, primarily the plastic blower wheel, to properly cool down. So my point is this. I'm going to just run over here are your potential points of failure. You could have a
is,
bad
is this
board.
is this a top 10 list, John?
It's a top 10 list. It's exactly
Oh,
what
I
it is.
love my top 10
Okay.
list.
Your board could be bad. It could be, and you have a 6-pin connector, without getting too deep. It could be failing in that respect. You have a motor. You have a sail switch, also known as our airflow prover. It proves there's enough proper airflow from the motor spinning the blower wheel. You have a high temperature limit switch. You have the electrode tower on the board. So you could have a
Oh, yeah.
6-pin that's working properly, but the igniter on the board side is not working properly. Then you have the other end of the electrode, which is actually the igniter. You've got the flame sense that could be failing. You have a gas valve, and you have solenoids. And that gives us 10 here. No, that actually gives us 9, but we're going to throw in bonus because your thermostat could be bad, but also if you have low battery voltage, that
Yeah.
can really mess with
That
any
could
of
throw
your
everything
component.
off.
It can throw everything off, right? And in fact,
Yeah.
when I work on furnaces, the first thing I do is
SWT.
That's right. I go to the battery, I go to the battery and I do a wiggle test and I check voltage at the
You
battery
check voltage. Yep.
to make sure our voltage is good. And then, because if I don't have 12 volts at the battery or 13 volts, ideally at the battery, I'm not going to have that at the board. And these things need it. And which brings us to my second my third point. My first point is that it's not always the sail switch, and in fact, quite often it isn't. And in one of these photographs, you can see the sail switch, and in this particular model, you can see the paddle, you can see where dust would collect. The big
Yeah.
thing about sail switches is people will talk about if you have dogs, cats, that the airflow will suck in air, suck in debris, suck in fur, and it can pile up and make dust bunnies, and it will prevent the sail switch from completely closing. That is a real thing. I think all of us techs have seen dirty sail switches,
Oh
but
yeah.
again, I think that's in the minority. Okay, when compared to the Facebook forums where 90% of the people are shouting it's a sail switch, regardless of symptoms. The second point I want people to understand is that you have about 10 potential points of failure in your
Mm.
furnace system. And you have to understand how these all come together to make this thing give us warm air. And the last one, which I actually think is the most important point, particularly for our techs, it's just I'm an experiment of one, but my experience has been validated by many other techs. I've replaced more blower motors than any other single component in an RV furnace. More than
Wow.
sail switches, more than high temperature limit switches, more than boards. So the motor, and understand this, the motor is a critical piece of equipment because one, it's turning the blower wheels, but it has to turn the wheels at a specific RPM. Because if you don't have them running fast enough, it might not close the sail switch.
Oh.
And sort of counterintuitively, if it is running faster than it should, it can close the sail switch. But if it's running too fast, it can cause the sail switch to begin to flutter.
Uh-oh.
And as soon as the sail switch opens up for a nanosecond, now the furnace is going to shut down because you see how it's not getting the connectivity through the whole circuit. So the
Oh,
nice thing for
interesting.
techs and for owners who have a multimeter that has an amp clamp, the first thing I do now when I open up a cover and I'm looking at a furnace and I'm testing it, the first thing I'm doing is checking my motor wire. So the red wire that comes off the board, if you can see the board, it's going to say blow, BLO for blower, and it's going to be a red wire that's going to run in. You can see right where it goes to the motor. I put on my amp clamp, and depending on the make and model of the furnace, probably should be somewhere around 9 to 10 amps. Okay. I just was
Okay.
working on one this week. I was getting 5 amps,
Oh,
way
that's not
underpowered.
good. Yeah.
That is not good. Okay. And then conversely, I've also worked on one that was running 15 amps. And this was the one that was fluttering. And the client's complaint was, hey, it starts up, it runs well, and then it shuts off, the furnace shuts off, the gas shuts off, the blower continues to run, and then the gas comes back on. The gas is coming on and off, on and off. And why is it doing that? Is that the sail switch would momentarily open up, which would tell the board, hey, this isn't safe. I don't have proper airflow. Shut everything down. So it wants to close the gas valve. Hence, there's no more heat. But then once it closes, now think of this as just the first step again in the ignition
Yeah.
sequence. So now the motor's running for 30, 40 seconds. Sail switch is closed. It's telling the board, yep, now we do have good airflow. Then the burner comes on and we
Because the
repeat the
temperature is still
cycle.
cold.
Yep.
Yeah.
Yes.
Okay.
So these
Well,
intermittent issues, those are my big three. One more time, cut you off here. I'm sorry. One, it is not always the sail switch, and it's probably going to be a minority time that it's the sail switch. Two, there's 10 points of failure. You need to understand what those 10 points are. and how they work together. And lastly, the blower motor is something to be checked right away. It's the easiest thing to get to. You don't even have to put the leads in your multimeter to test this, like to test the sail switch for continuity. Pull out your amp clamp, throw it on the wire, call for heat. You don't even even if the furnace isn't coming on, the blower has to be operating at its proper amp draw because that
Right. Right.
translates to RPMs for proper function.
Okay. Well, thank you for that very well thought out, very in depth flow chart of the logic sequence for a furnace. But John, I'm going to put you on the spot now. And dear readers, I know this is pre-rehearsed, but I'm going to ask some of the questions that our listeners want to know. So picture this as the audience at large asking John, the furnace man, Vanek. So let's
Go
start
ahead.
with a couple easy ones for you. You've talked a lot about the sail switch. I understand. Kind of curious now to see one in real life, or if I have one, where would the sail switch be?
So typically, well, here you run into issues. So if you're lucky, you have an exterior access panel, and we'll put up a photograph. You'll see here's a furnace that has an exterior access panel. Unfortunately, not all RVs have the exterior access panel, which probably means it means you have to come in from the back and remove the entire furnace from the back side
Oh,
and pull it out of the rig. All of a sudden we're talking time and effort just to get the furnace out so it can be worked on and diagnosed. But I'll put up another photograph here, and this is kind of your typical view. And this is actually professionally, this is referred to as the back of the furnace. But here's where the important stuff is. And you can see in this particular photo, the sail switch is visible in the sense that you can see the paddle, you can see the button for the micro switch. Sometimes they are on the inside of a cover, but you're going to see these two wires coming together, and there'll be a little plate with a couple of screws. And if you take those screws out, you can carefully pull out because you're going to have a thin metal blade. It's going to be of different designs. It might have some bends in it depending on the make and model of the furnace. But you pull that out, and there's your little micro switch with the blade there. So it's something
okay.
that is essentially right in front of you.
Okay. So, next listener question. I can feel these coming in, by the way. Um, and if you want to add to this list, by the way, dear fans, contact us at smart-rv.com. So, John, what should I do? I have a furnace. I enjoy being warm, and I have two lovable dogs. Maybe they shed a lot, and I've got a nice filter in my house. Can't I put a filter in the return?
No, no, not a good idea. Because again, these are small systems, and they're balanced in terms of what they need in terms of airflow, and then again what they're going to push out in airflow. And because some RVs have a very tiny cabinet that the furnaces might sit in, some actually have an air intake on the outside. These all vary. And so, but the last thing you want to do is impede the return air getting to the furnace, because if
Okay.
it's not getting enough fresh air that's getting sucked into the burn chamber, because it's calibrated to keep it at below that high temperature limit. So if we're not getting sufficient airflow, that air will warm up, and then it will begin to trigger your high temperature limit switch. So it's a good idea to understand where your returns are for your furnace, where the air is coming from that's going into the system, and absolutely do not block that. It'll be a vent. Typically, if you don't have if it's an internal return, the vent is going to be maybe 24 inches by 12 or 16 inches. That's going to be a louvered panel of some type. It's going to be obvious. It's going to
And,
be in the open area of your RV. Do
and
not block it.
it will always be central. It's never going to be on the extreme front or rear view rig.
Probably not, because again, just you were talking about wiring earlier. You want things central, so you're running ducting.
Right.
Um,
Right.
but that can also be, centrally located is also a variable.
Relative
Centrally
term.
located is within the middle third, right? You could
Exactly.
have
Yep.
it, you could have it at the edge of one of those,
Yeah.
and it's making a long run to the end of the RV.
Right. Right.
Next question.
Okay. So for our last listener question that I can feel coming in, contact us at smart-rv.com. What is going on, John? I have a furnace and it's provides good heat, but man, when I'm outside and I'm getting my s'more kit together and I'm walking by and the campfire's roaring right there, boy, I noticed I've got a ton of heat gushing out of the side of my rig. Do I have a leak? Is one of my furnace lines
Ooh.
gone astray? Shouldn't that be going inside? What's happening there?
Yeah, good question. Excellent question, as you would say. That is your exhaust from the burn chamber. So again, the furnace is essentially it's sucking in air. It could be coming from the outside. If you look at the outside of your rig and you have two ports, one is drawing air in, the other is pushing air out. If you only have one, that means you have an air return somewhere on the inside of your RV. That's sucking in the air. So imagine the air gets pulled in by the blower wheel. It gets pushed into the burn chamber where the flame is. That air is now making a circuitous route through the burn chamber, and it's just getting that chamber really hot. And that hot air has to come out somewhere. And that's the hot air you feel coming out the side, outside of the RV. That is the
Okay.
hot air that has gone through the burn chamber and out. And just so you understand that the furnace is mounted in a case. It's a sheet metal case, and the blower wheel is just blowing air over that hot burn chamber. That's how the air gets heated that is
Mm,
then pushed into your rig. So the air with all the gases, with the burned LP coming out, that should never, ever, ever be going into your rig.
okay.
So if by some chance you should ever start smelling a burning smell, or because burn chambers over age and time, they can crack, they can develop little pinhole leaks, and if you're smelling something that smells like it's burning, shut everything down and call a tech and have them check out your furnace to make sure you don't have one of those types of issues.
Okay. So for our engineer fans, what John described, and this can be properly labeled as an air to air heat exchanger, drawing air in from the outside, effectively superheating it, and then releasing it back to the outside. But while it's superheated, taking interior air, passing over this metal circuitous ductwork system and heating interior air and then releasing it back into the interior. And so that's what keeps us safe and allows the carbon monoxide and other LP burnt off gases to escape outside.
That's right. And my final word for RV owners, if you're interested, we always talk about knowing your rig. So you should understand the make and model and even the serial number of your furnace, as with all of your other appliances. But if you're concerned about these issues, particularly if you live in cold areas during the winter and you don't want to be without your furnace, you know what? Sale switches are probably, $25-$30. If you order this right sale switch, have it in a drawer. If you do have a failure, you've got it. You might want to do the same with the proper high temperature limit switch. Again, it's a very inexpensive piece. And actually, it isn't the final thing because there is one other option. If you have an older rig or if you're having multiple issues with your furnace, another option to consider is what's called a core replacement.
Oh, is that where you replace the entire furnace, John?
Yes, it is. And just recently, I had a client says, "Hey, my furnace isn't working. I went out." You should be able to kind of reach in, depending on the design. You should be able to reach into the actual blower wheel and kind of manually turn it, not while it's
Right.
running, but to make sure that it spins. And this thing was completely locked up. I mean,
Oh,
so I'm like, "Sir, you need a new motor." Okay. Took me about 2 minutes. You need a new motor. And, but this was almost a 20-year-old Class A, beautiful shape. And he did make the comment that it really didn't seem to provide a whole lot of heat. So
Yeah.
I said, well, here's the deal. It's going to take me this much time to pull this thing out, go home, take a motor, order a motor, get the motor. You have to pay for the motor. I've got to tear this apart to put the motor in,
Yeah.
put it all back together, bring it back, reinstall it. And, it's 20 years old. The board could die tomorrow. The burn chamber could crack tomorrow. So for, I want to say somewhere around $500, we bought a new core. And it took about less than an hour to pull out the old core, put in the new core, reconnect the LP and the wires, fired this thing up. He went inside, and in about 10 minutes, he was coming out asking me I was letting it run to test everything. He asked me to turn it off because it was too hot.
Are we done
And
testing?
and not only was he impressed with how quickly the inside got hot, but how quiet it was, which is another
Oh,
issue that can be related to age.
yeah.
So at a certain point, you might want to think about a core replacement. It's probably going to be cheaper. You're going to have all new components. It replaces everything except the metal, sheet metal case and the ducting. Easy.
Okay. And so that's something a qualified tech, depending on the floor plan and layout, may not have too much trouble with.
They should not.
Okay.
And again, if it's difficult to get to, I mean, I was working on another rig last week, did not have an exterior access panel, just because of the positioning. It was a lot of work to get it out and put it back
Yeah.
in after the fix. But once I got it out, it still would have been if we weren't at that point because it's a newer rig, it's a newer furnace. We weren't really discussing a core, but it still would have been faster to replace the core than to diagnose, bench test. In this particular case, it was this LP issue that is a good topic for another time. But in any case, it was a lot of time spent diagnosing and getting this fix. But core replacements, if you got to pull it out, it's still going to be faster to do a core replacement. So you want to be comparing the time of diagnostics and additional cost of new parts versus buying a new core. A rule of thumb is that when you're looking at 50% of the cost of a replacement piece, no matter what it is, that's when you want to start thinking, hey, maybe it's just better to replace. And if you can buy a new core for $500 plus shipping, etc. It's not hard to reach $300, $400 in a repair for a furnace, particularly if it's difficult to pull out and access.
Wow.
Something for people to think about. A
Yeah,
core
that's
replacement.
definitely a good consideration, and thank you for letting our listeners know that's even an option. So
Yay.
great news there. And I really like having, first off, definitely like having your expertise, and I like having this episode, having this documented now. We'll be able to refer fans to this episode in the future. I think this is a great reference.
Well, Joe and I, being different parts of the country, different climates, we handle different types of calls along with the same types of calls. So probably, maybe like, I don't know, second week of January, third week of
Yeah,
January,
yeah.
we'll be talking to Joe about air conditioners because the people in Gulfport, Mississippi, they're going to be complaining that their air conditioners aren't working, right after New Year's Day.
Yeah,
Uh,
exactly. Air conditioning season here does take a break around Christmas, and that
there
seems
we
like that's
go.
about it.
Well, it's been one of our longer podcasts. We hope this has been useful. Again, the Symmes Wiggle Test. Whenever you're touching something, be careful. Make sure, particularly if it's the 110,
Yeah,
120, do be
yeah.
careful around that. But your battery cables, always check them because things rattle, right? Um, Keep in mind that your power distribution panel has different torque values for the different components in there. And those torque
Hmm.
values will typically be on a label inside the cover of your power distribution panel. And If you have furnace issues, understand, I hope this is explained how they work, how there's many components in there. The sail switch, might be it, but it might not. And certainly for our techs, or anybody owners, if as long as you have an amp clamp, throw that on your blower motor wire, and right away, it's the easiest thing to check. And hey, see, someone's calling me right now. They need a furnace fix. So, so there you go. Last
More
words, Joe.
No, I can't thank you enough. All the furnace words of wisdom, and our fans are appreciative. So thank you very much, John.
All right, buddy. Well, thanks again, and we will see you next week at the Smart RV Podcast. Remember, any questions you have, email us. Our email address is,
Contact us at smart-rv.com.
and with that, we'll see you next week. Take care, Joe.
So long, everyone.